Hello and Assalamualaikum to all. We are going to proceed to chapter 4.2, Stoichiometry. Learning outcome. At the end of the lesson, you should be able to calculate the reactant and product from a balanced chemical equation. And the calculation that you need to calculate is actually related to mass, mole, volume of gases, and volume of solution and concentration of solution. So stoichiometry, what is stoichiometry? So it is a quantitative relation between number of mole, so it is important here, mole of reactant and product. So whatever you do for stoichiometry, we need to find the number of mole first. For example, this one, calcium carbonate, HCl, CaCl2, CO2, and H2O. So what is the relationship in terms of stoichiometry here? So we can say that 1 mole of calcium carbonate react with 2 mole of HCl. Okay, this is 1 mole. Calcium carbonate here is 1 mole. React with 2 mole of HCl, 2 HCl. So that is the relationship. 1 mole and 2 mole. 1 mole of CaCO3 also produce 1 mole of CaCl2. Okay, if I write down in short form, it will be like this. 1 mole of CaCO3, okay, produce 1 mole of CaCl2. This triple dash here means that it can be react, it can be produce, it can be anything. Okay. Okay, 1 mole of CaCO2 also produce 1 mole of CO2. Okay. 2 mole of HCl. Okay, if we want to use HCl as the relationship, 2 HCl, 2 mole of HCl, 2 mole of HCl produce 1 mole of H2O, and so on actually. 2 mole of HCl also can form 1 mole of CaCl2, and 2 mole of HCl also produce 1 mole of CO2. Okay, so that is the relationship between reactant and product. So stoichiometry is about the quantitative relationship. Okay, so let's look at the example here. How many moles of the hydrochloric acid? Okay, we are looking for this one. Do we need to react with 0.5 mole of zinc? So if we have 0.5 mole of zinc, how many mole of HCl that we need? Okay, so for you to do this, you need to find out the stoichiometric relationship first. Okay, so 1 mole, you write down 1 mole here first. Okay, this is from equation. 1 mole of zinc need 2 mole of HCl. Okay, 1 mole of zinc needs 2 mole of HCl. Okay, that is from the stoichiometry. That is from the balanced chemical equation. So if you have 0.5 mole of zinc, okay, if you have 0.5 mole of zinc, how many moles of hydrochloric acid? So write down here. Okay, this is about zinc. 0.5 mole of zinc. Okay. Okay, this is 0.5 mole of zinc. So how many moles? I write down X. X means something that we don't know lah. How many mole of HCl that you need? Okay, so this is actually easy. You just cross product. So this one cross product with this one, and this one will cross product with this one. So 2 times 0.5. So 2 times 0.5, this is cross product, equal to X times 1, or 1 times X, the same thing. So you should calculate, and X is actually equal to 1, right? 1 mole. 1 mole of what? Okay, X here. Remember, X here refers to the one thing that you are looking for. So this X. Okay, so X here refers to the number of mole of HCl that you are looking for. So it is actually 1 mole of HCl. And if you write this down again, it means that if you have 0.5 mole of zinc, you actually need 1 mole of HCl. Okay, so that's the answer for this question. If you have 0.5 mole of zinc, you need 1 mole of HCl. So after it react, then you can get zinc chloride and H2 gas. Okay, what about this one? Example 2. How many mole of CO2? Okay, how many mole of CO2? We are looking for this one. Will be formed when 0.25 mole of the reactant. Okay, this is the reactant. C2H5OH burns in oxygen. This is the oxygen that it burns. So as always, find the relationship in the balanced chemical equation first. Okay, this is a balanced chemical equation. Okay, this is a balanced chemical equation. So we can write down 1 mole of C2H5OH will produce 2 mole of CO2. Okay. So if you have 0.25 mole, okay, the process is the same. 0.25 mole of C2H5OH. This one we don't know. So X. Okay, how many mole of CO2? We don't know. This is from the stoichiometry, yeah. So we don't know. And cross product again. So 2 times 0.25 equals to 1 times X, or X times 1. So 2 times 0.25 is equal to 0.5 mole. And this mole refers to this one, CO2. Okay, so if we write again, so if we write down again, 0.25 mole of C2H5OH will produce 0.5 mole of CO2. Okay, so this one is very easy, right? Just a simple ratio, just a simple comparison. Okay. Okay, there is question 2. Okay, there is question 2 there. What is the volume of CO2 in question 1 here if the combustion happens at STP? Okay, this one you need to relate to volume of gas at STP. Okay, 1 mole of any gas, it doesn't matter what gas you have, will occupy 22.4 liter at STP. STP refers to standard temperature and pressure, which is 0 degrees Celsius and 1 atm. Okay, any gas here, because we are talking about CO2, so we actually referring any gas here to CO2. So we already calculate earlier, the mole of gas that you get from question number 1 here is actually 0.5 mole of CO2 gas. So what is the volume? Again, X, because we don't know. We are going to calculate this one. What is the volume at STP? So cross product again. 1 times X. Okay, it doesn't matter whether you want to put on the right or on the left. It doesn't matter. Okay, 22.4 times 0.5. 22.4 times 0.5. So X is actually 11.2 liter. Okay, liter of what? So X here refers to the volume of CO2 gas at STP. Okay, so 11.2 liter of CO2 at STP. Okay, so that is the volume of CO2 that it will occupy if the combustion happens at STP. Okay. If you have question, you can ask in the Telegram. Okay, next one. Exercise 1. This one we are going to relate to mass. Okay, the question asks you, what is the mass of aluminium hydroxide? Right, aluminium hydroxide. How many grams of aluminium hydroxide? This one we don't know. That will react with 5.3 moles of HCl. Okay, again, HCl is here. So we are looking the relationship with aluminium hydroxide. Aluminium hydroxide. Okay, aluminium hydroxide. So this is the same thing. So the relationship that we can find from the equation, from the balanced chemical equation, is that 3 mole of HCl will react with 1 mole of aluminium hydroxide. Okay, the question asks you if you have 5.3 mole of HCl. So if you have 5.3 mole of HCl, how many mole of aluminium hydroxide that you need? Okay, why do we need to find mole? You are actually looking for mass. Okay, if you remember from the slide number 2, I already told you that stoichiometry, we are always relate it to mole first, and then to the mass, to the volume. It must relate to the mole first. You need to find mole, and then we are going to relate to mass. Okay, so let's try to find mole first. Okay, so 3 times x and 1 times 5.3. Okay, this one is cross product. So 3 times x equal 1 times 5.3. So x equal 1 times 5.3 over 3. Okay, this one I need to calculate. 1.77. Okay, 1.77 mole. Okay, so what is 1.77 mole? This is x. What you calculate is 1.77 mole of x. Okay, x is this one. Okay, so x is mole of aluminium hydroxide. Okay, x is mole of aluminium hydroxide. So you get AlOH3, which is at 1.77 mole. If you have 5.3 mole of HCl. Okay, so that is the relationship. So if you have 5.3 mole of HCl, you actually need 1.77 mole of aluminium hydroxide. The question asks you about mass, about gram. Okay, it asks you about gram. So this one, you need to relate to the mole to the mass. Okay, so mass is actually, okay, sorry. Mole is actually mass over mr. Okay, mole is actually mass over mr. So you are looking for mass. Okay, so mass is mole times mr. So mole we already find out here. Okay, the mass that we are looking for is the mass of aluminium hydroxide. So the mole we must look at the aluminium hydroxide value here, 1.77 gram per, sorry. This one is not gram per mole. This is only mole. Times mr. Mr is gram per mole. So mr is already given. Okay, mr of aluminium hydroxide given. So 1.77 mole times 78 gram per mole. So the unit of the mole will be cancelled off. So you will get the answer that is 137.8 gram. Okay, so what is this? What is this value? This is actually mass of aluminium hydroxide. So this is the final answer of mass of aluminium hydroxide. And how we find it? How we find the mass? Okay, based on stoichiometry that we relate with mole. So remember, we need to always relate to. Okay, there is second question from the same question. There is second question here. Okay, what is the quantity of HCl in gram? Okay, this time it asks about HCl. What is the mass of HCl? If you have a tablet of 0.50 gram of aluminium hydroxide, consume means react, mean HCl react with aluminium hydroxide. So what is the quantity of HCl that you need? So again, the relationship stoichiometry. So you just write down. So 3 mole HCl, 3 mole, okay, 3 mole react with 1 mole of aluminium hydroxide. Okay, so when it is not written here, it means that this one is what actually 1. Okay, so what quantity of HCl in gram can a tablet with 0.50? So we don't know the number of mole for this one. Okay, so we need to find the mole for aluminium hydroxide. Okay, so we need to find the mole for this one. So the mole is mass over mr. Mass over mr. So mr for this one is 0.750. gram over mr. Mr is given earlier, 78 gram per mole. Okay, so you will get a 9.62. 9.62 exponent negative 3 mole. Okay, so this is the mole of aluminium hydroxide. So this is the mole that we need to relate stoichiometrically. Okay, so if you have 9.62 exponent negative 3 mole of aluminium hydroxide, how many mole of HCl will it react? Okay, even though we need to find mass, we need to relate with mole first, right? So cross product. So 1 times X equal to 3 times 9.62 exponent negative 3. So you need to calculate this one. So X is equal to 0.029 mole. Okay, so the value 0.029 mole, what is this value? It is the value of X. And what is the value of X? Mole of HCl. So what you calculate here is the mole of HCl. And after you already get the mole of HCl, you can now calculate the mass of HCl, right? You can now calculate the mass of HCl. Mass of HCl. So what is the mass of HCl? Mole times mR, right? Okay, so the mole 0.029. Okay, this is the mole 0.029 mole times mR. mR is this part given for you HCl 36.45 gram per mole. So you should calculate this one using calculator. So 1.05 gram. Okay, and what is this mass? The mass that you calculate is actually the mass of HCl. So the mass for HCl the mass for HCl is 1.05 gram. Okay, so this is the answer. Okay, this is the answer based from our calculation. Okay, next exercise 2. This one we want to relate to volume. Okay, this is volume. Volume. So how many milliliters of HCl that will react with sodium carbonate? Okay, so from the stoichiometry, write down first the relationship. So 2 mole of HCl will react with 1 mole of Na2CO3. Okay, so that is the relationship. And then the question asks you how many milliliters. How many milliliters? Okay, we don't know the volume yet. So what you need to find out is actually the mole. Okay, the mole of sodium carbonate. Okay, this part. Okay, this part. So how can we find the mole for sodium carbonate? Okay, you should remember that molarity is N over V, mole of solid over volume. So for you to find mole, okay, for you to find mole, it means that, okay, this one you need to do it like this. Okay, I always write down like this. So M equals to N over V. So if you are looking for N, it means that M times V. Okay, so M times V and V. And the V here must be in liter. So molarity, do we know molarity? Okay, molarity we know. This is the molarity, 0.150. 0.150 molar. Volume, do we know volume? Yes, we know the volume of sodium carbonate, which is 21.2 milliliter, but it needs to be in liter. So you need to divide by 1000. So calculate. So you will get this one. This one is 7. No, not 7. 3.18. 3.18 exponent -3 mole. So what is the mole that you calculate? It is mole of sodium carbonate at 22.2 milliliter with 0.150 molar. So you write down at this part 3.18 exponent -3 mole of Na2CO3. So this one we don't know. So X. And if you see the pattern like this, so it means that you need to cross product. 1 times X equal to 2 times 3.18 exponent -3. So you calculate and the answer will come out 7.6 exponent -3 mole. And what is the mole that you calculate here? It is X. And what is X? X is mole of HCl. So 7.6 exponent -3 mole of HCl. The question asks you about volume, milliliters. Okay, again, molarity is equals to N over V. Now you are looking for volume. Okay, you are looking for volume. Okay, if you refer back to the triangle that I draw, M, M, and V. Now we are looking for volume, right? So if you try to calculate for volume, it means N over V, N over V, N over M, N over M. So V equals to N over M. And this one is for HCl. We are going to calculate for HCl. So for HCl, the number of mole is this one. 7.6 exponent -3 mole over molarity. Molarity is this one. Given already. 0.112 molar. So you calculate using calculator and the answer will come out 0.0678. And remember, this one is liter because molarity, the unit is mole per liter. Okay, so I can change this one into milliliter, 67.8 milliliter. And what is the volume that you calculate? It is volume here which relate to HCl. So now, how many milliliters? It is this one. Volume of HCl is equal to 67.8 milliliter. So this is your final answer. Okay, so that's it about stoichiometry. So what you need to do is to study more about this and try to do some exercise. So good luck. Don't forget to like and subscribe.